In this video, we're going to talk about constructing the images from an object when the light is reflected through the mirror. And we're going to differentiate two types of the mirror. One is going to be called as a concave mirror, and another one is a convex mirror. At the same time, we're going to define the basic notation, the formulas, and also we'll do the examples and also a bit of simulations. So let's define first of all the notations. So here we're given the mirror. This mirror is going to be a concave mirror. And for this structure, so we are going to define this line as the principal line. All the things here are going to be called in the front side, and everything here is going to be called as the behind, front and behind. This is important because every item here on the front side is going to be positive, and every item here on the behind is going to be negative. So if we just make a circle, if we just continue this mirror and create a circle, the radius of the circle or center of the circle is going to be here, and half of the radius of the circle is going to be denoted as the f. We call this as the focal point. For example, if we are given a mirror, we're going to create a circle. If the circle radius is equal to the 4 centimeters, and then the focal point is going to be 2 centimeters from the mirror. So the focal point, if this is in the front side, if the focal point is in the back side here, it's going to be denoted as a minus 2 centimeters. So here, the center of the curvature, it's when we are going to continue this mirror and create a circle, and this is going to be the center, which is equal to the 2 focal points, and the focal point is going to be the half of the radius of this curvature. So now we're going to define an object. So let's say we've got an object here, and so the light which is going from the object and reflecting through this mirror is going to create an image. So this is what we are going to find actually. So we are going to define the height of the object as a HO, and also we're going to define the distance between the object and the mirror. So there is an equation which is going to be called as a mirror equation, which is going to connect the distance between the object, the focal distance, and also the distance between the object image and the mirror. So we're going to define this mirror equation as 1 over f is equal to the 1 over distance between the object and the mirror plus 1 over distance between the image. So we are going to create an image somehow. So actually we're going to create an image in the same way as we may do for the thin lenses. So we need to do this in a procedure of the 2 steps. The step number 1 is we need to create a line which is parallel to the principal line, and whenever it reflects from the mirror, it should go through the focal point. So the parallel, then focal. And another one is we need to create a line which is going through the focal point and parallel. So focal and parallel. So let's do this. So we first of all need to create a line which is going to be parallel to the principal one, and then goes through, reflected through the focal point. And the second one should goes through the focal. Whenever it reflects, it's going to be parallel, and the intersection point is going to be our image. So here there is an intersection point, right? So this is going to be our image. So that we are going to define the height of an image Okay, in this case, the height of the image is going to be positive. For example, if the height of an object here is equal to the 3 centimeters, and here you can see that this is the tiny image, it's going to be, for example, minus 0.3 centimeters, right? So since it looks down, so we are going to define this with a negative. And also we're going to define the distance between the mirror and the image, and this equation actually allows us to find the distance between the image and the mirror if we know the distance between an object and the mirror and the focal side. So there is an equation which is going to connect the height of an image and height of an object as well. So this is called the linear magnification. We're going to define the linear magnification as a ratio of the height of an image over the height of an object. At the same time, it is connected with the distance between the image over the distance in the object with the negative sign. So these two equations allows us to find the distance between the image and the mirror and also its height. And basically it allows us to construct the images from the object. So let's do an example here. So we've got an object which is going to be 10 centimeters away from the mirror. So the focal distance is equal to the 5 centimeters. And what we need to do is we just need to create an image. So first of all, we are going to find the distance between the image and the mirror using the mirror formula. So it's going to be 1 over f is equal to the 1 over dO plus 1 over di. So what we have to do is we need to find the di. So in order to do, we are going to subtract minus 1 over dO from the both of the sides of this equation. It's going to be 1 over f minus 1 over dO is equal to the 1 over di, right? So let's put everything together, all the numbers. So 1 over 5 minus 1 over 10 is equal to the 1 over di. So if we give the common denominator here, so we just need to multiply this to the 2. It's going to be 2 minus 1 over 10, which is equal to the 1 over 10, right? So 1 over 10 is equal to the 1 over di, which tells us that the distance between the image and the object and the mirror is equal to the 10 centimeters, right? So somewhere we've got an image and the distance between the mirror and the image is equal to the 10 centimeters. Again, so what we need to now do is we would like to know how this image looks like, whether it looks up or down, and what is actually its height. In order to do this, we need to use the second equation, the equation of the linear magnification, right? So which is equal to the hi over ho is equal to the minus di over do. So what we have to find, actually, we just need to find the height of the image, because we're given the height of an object, we're given the distance between the image and the mirror, distance between the object and the mirror. So in order to find this, we are going to multiply both of the sides of this equation to the ho. It gets roots of the ho on the left hand side, and what we're going to have here is hi is equal to the minus di over do multiplied to the ho, which is equal to minus di is equal to the 10 over 10 multiplied to the ho, which is equal to 4 centimeters. Right? If we simplify everything, we're going to get minus 4. What does it mean? It means that our image is going to be 10 centimeters away from the mirror, and its height actually is going to be minus 4. It means that it's going to look down. Though this is going to be our image, minus 4 centimeters. Okay, so actually we can get this image using by doing the ray diagram. So we need to do this in a 2 steps. The step number 1 is we need to draw a line which is going to be parallel to the principal line, and then going through the so it should go through exactly the focal point. So this is going to be the first one, and in order to do the second one, so the line should go through the focal point first of all. Then it should go through. Then it should go parallel. So roughly, so we should try to sketch this properly. Well, so whenever we sketch this properly, it should be correct. So we can check this by doing the simulations using the sim bucket simulation here. So I've gotten focus. So for focus 1, it should be. So let me update this. So we need to change this as a mirror. So the distance. We can change the distance, and also we can change the focus length. Well, for example, 20 centimeters. So whenever we're going to put an object onto the 2 focus, or to the center of the curvature, image should be the same as an object, but it's going to look down, right? For example, let's make an arrow. If I put this exactly onto the 2F or onto the center, we're going to get this image. So let's change the height. And actually we can try to do this doing the 2 rays. The ray number 1 is going to be parallel and then through the focal point, and the second one is going to be through the focal point and parallel, and intersection is going to be the image. And we can find the height of the image and the distance between the image and the mirror just using these 2 equations. So now let's do an example on the convex mirror. So this is our convex mirror. What we're given is, we're given that the image height, the object height is equal to the 2 centimeters. The distance between the object and the mirror is equal to the 8 centimeters. And the focal point now here is going to be on the behind, right, on the back side. So that's why it's going to be minus 2 centimeters. First of all, we're going to find the distance between the image and the mirror, right? So in order to find this, we need to use the mirror equation. It's going to be 1 over f is equal to the 1 over do plus 1 over di. We need to subtract minus 1 over do from both of the sides of this equation. What we'll get is 1 over f minus 1 over do is equal to the 1 over di. So let's put everything together here. It's going to be minus 1 over 2 because the focal point now, or focal distance, is going to be negative 2, minus 1 over 8. It's equal to the 1 over di. If we give the common denominator, it's going to be 4 here. So it gives us that 1 over di is equal to minus 5 over 8, right? So it's going to be minus 4, minus 1 is going to be minus 5 over 8. So please note that the distance between the image and the mirror is not equal to the minus 5 over 8. Its reciprocal is equal to the minus 5 over 8. It means that if we would like to find the distance between the image and the mirror, we just need to take the reciprocal of this number, which is going to be minus 8 over 5, or which is equal to the roughly minus 1.6. So basically, the distance between the image and the mirror is equal to the minus 1.6 centimeters. So now what we need to do is, I would like to know what is the form of the image, so whether it looks up or down, and what's going to be its height. In order to do this, we need to use the second equation, the equation of the linear magnification, which tells us that height of the image over the height of the object is equal to the minus distance between the image of the mirror over the distance between the object and the mirror. So we're going to multiply again both of the sides to the HO, which allows us to find the HI. So the HI is going to be equal to the minus DI over DO multiplied to the HO, which is equal to minus, so the distance between the image and the object is equal to the minus 8 over 5 divided to the distance object, and the distance between the object and the mirror is equal to the 8 multiplied to the height of an object is equal to the 2, right? So basically this is also was the minus, because the distance between the image and the mirror is equal to the minus 8.5. So we're going to cancel this 8 and 8, this 5 goes down. What we'll have here is minus 2 over 5, or plus 2 over 5, sorry. It's going to be equal to the 0.4. So basically this image is going to be 5 times smaller than the object. So its height is going to be equal to HI is equal to the plus positive 0.4. It means that it looks up. So this is going to be our image. And we need these two equations in order to find the distance between the image and the mirror and also its height.